All right, perfect. Well, it looks like we got a good cohort of folks, so we'll go ahead and get started. Thanks so much for joining us for this morning's webinar, AI-Ready Architecture for NVIDIA Partner Network Cloud Partners. Sorry, that's a mouthful. The next generation of data center architecture for AI cloud service providers. Just a couple of housekeeping things before we get started. At any time during the event, if you have a question, feel free to drop it into the Q&A. If we can jump in and take it during the session, we will. If not, then we'll take it in the Q&A section. And for some reason, if we run out of time for answering questions, we'll get you a question after the event concludes. We'll get your question after the event concludes. But with that, I would like to welcome today's speakers, John Mao and Michael Lang. Welcome, John.
Hi, good morning, good afternoon, good evening, everyone. My name is John Mao. I am the VP of Global Business Development and leading the Alliances team as well here at Vast Data. We are responsible for our partnership globally with NVIDIA, and I'm extremely happy and honored to be here today to talk a little bit about some recent announcements. And I'm joined by Michael Lang, who is one of the leaders of the Solution Architects teams based out of Australia. So you want to say hello, Michael?
Yeah, good morning, and thanks, John, for being here. As you mentioned, I lead the Solutions Architecture team for both Southeast Asia and ANZ, based in sunny Melbourne. So looking forward to the session today.
Wonderful, wonderful. Well, we're going to jump right into it. We called this cheekishly, a conversation chat really about AI infrastructure at scale, specifically in the context of NVIDIA Cloud Partners. And as many of you know, AI infrastructure is really not your grandpa's infrastructure. It's not maybe some of the infrastructure that many of you are familiar with if you've come from a service provider or an IT background. But we're going to dig into that in just a second in much more detail. But to kick things off, maybe Michael, we see Jensen and NVIDIA all over the news these days for good reason. And there's this term that I hear Jensen talk about often, that he coins AI factory. Maybe we could start off with just an easy conversation, just to help us understand what does he mean when he talks about AI factory? What do you guys mean at NVIDIA when you're describing this kind of new paradigm here?
Yeah, look, it's a really important question because, as you pointed out, this is not really the same infrastructure necessarily that enterprises or service providers have done in the past. It looks different, it acts different, it has different outcomes, and it's composed of different things. And of course, given the trajectory that customers have on their AI journeys, you'll need to cater for different things as well. So Jensen likes to talk about three stacks. There's the data stack, which obviously is critical because without data, there's no AI. There's the accelerated compute stack. And some people hear that and think, compute, I've done that before. But again, the term really is accelerated compute. And that's a bit about both the hardware and the software piece there as well, and all the underlying components. And of course, there's a model stack. Again, AI has a fairly unique set of tooling that's quite different than traditional enterprises have had. Windows, even some Linux workloads or virtualization, it does different things. And that software stack also is really highly subject to change as well. So given the tooling that data scientists and people use, at different times in their life cycle, you need to be able to make sure that you have all that modern tooling there. Otherwise, you can't do the data science, you can't do AI. So the AI factory term is really a couple of things, but again, it's think differently. It's not what you've used in the past.
Yeah, I like it. It kind of gives this mental picture, right, of creating new types of intelligence, creating new types of insight, right? And I know that you all talk a lot about, like you just mentioned, right, kind of these multi-stacks, but I think maybe you could share a little bit about just kind of the role, and we're going to talk a lot more about this in a second, but what do you typically see in these AI factories when you talk about inputs and outputs typically? What goes into a lot of these large language models that we keep hearing about, right? And how do you guys articulate this maybe in a simple way for the audience who may be just coming kind of new onto the scene here?
Yeah, so I suppose the simplest you can get with I/O really is around data goes in and intelligence in the form of tokens comes out if you're inferencing, or models if you're training. And again, different levels of outcomes there for life cycles. But this is where really understanding the customers and what they're trying to achieve. There's a level of complexity in the middle that, of course, as a CSP, we want to simplify that. We want to make that as easy as possible for people to consume and grow over time. But the outcome here is different. And obviously, there's a focus here on this slide about generative AI. This doesn't eliminate the possibility of using, and I can't believe I'm going to say this term, traditional AI, which up until a year ago was all the AI, but that's still very commonly used. So again, deep learning versus inferencing, and again, the models you use there and what you do, but this is all the pipeline consideration. But it's a little bit varied depending on what people do. But I suppose the key thing that the customers are after at the end there is they want the business value and they want the time to value to be as rapid as possible with reduced complexity. And again, as a hoster here, we want to simplify that, but give them the best possible outcome and performance possible.
That's great. So, obviously this is, a global phenomenon we're seeing, right? You're sitting in Australia, I'm sitting in the United States. I hear about just the level of interest, and we as a company at VAST, we see the interest globally, right? There's interest in large language models because frankly, at the end of the day, native languages are important, right? If you can have an AI model that understands every single native tongue, every single native language, it's pretty interesting. So let's shift a little bit into the conversation today around our service provider friends and partners. Given what I just described in terms of some of the interest globally, what have you seen from your part of the world, regionally, right? From an AI perspective, and maybe as we kind of transition into the conversation around NCP or NVIDIA Cloud Partners specifically, maybe you can also talk a little bit about what exactly is the NCP program? Why did NVIDIA really establish this, right? What is the genesis of the program as well?
Yeah, it's a great question. Things come from demand. So what was the demand and where did it come from? So in the APAC region throughout Southeast Asia and ANZ, there's different needs. And some of those are driven by just plain requirements. So for example, I've got customers in Thailand and Vietnam that had to create their own large language models purely because of language. In other areas, there's a degree of sovereignty around the AI that's demanded at a national level or desired there. At the enterprise level, some customers have indicated they don't wish to own as much infrastructure as they want. But traditional hyperscalers may be N-1 or in some cases N-2 for the latest GPUs and software stacks and the like. So that can be challenging. So when some of the larger providers came to us and said, hey, NVIDIA, you've got experience doing this. You've consumed your own dog food. You've built large supercomputers. You've got multi-tenant requirements for your internal users. What does it look like? How do we do it? What's best of breed? And that's where we came up with the reference architecture for CSPs. And there's a few different elements to it, but at the end of the day, it's designed in the way that we're saying, CSP hosters make life easy for customers. We're trying to make life as easy as possible for CSPs so that you can say, okay, we know this is going to work. We know it's going to work well. It's given us a trajectory of whatever we need to do in the future, or if we start at size X and then go to Y or 2X or 3X, we can cater for that. And again, given some of these components here are different to what CSPs may have had in the past, whether we talk about the networking piece, the storage piece, the compute piece, or the software piece, we've got those architected and built in there. And again, this comes to the last point here around time to market, and the customers are going to demand quality experience. And whether we talk about the tooling or the performance or the combination of the two, all these elements are concatenated here to make sure that there's a lot of thinking that you don't have to do, and we're more than happy to expose design decisions and criteria there, but making sure that you can get going as fast as possible, best of breed, best possible outcome, both for you, including management, and the customers as well. So it's quite a few different pieces together. And there's even a comment there about our professional services team, NVIS, which assist in cluster deployment and things like that. So lots of things that are actually quite even unique to the NCP program that aren't available to end customers. So yeah.
So NVIDIA has had obviously years, if not decades, of experience building large scale infrastructure, right? Accelerated compute infrastructure specifically. And I think you guys know a thing or two about kind of designing for peak performance, right? You talked a little bit about kind of the reference architecture as part of the NCP program. I'm sure there's a lot of folks on the call that maybe some are already well versed, but maybe some don't know kind of all of the key things that go into some of the design considerations, from compute, networking, storage, et cetera. Maybe you can walk some of our audience through, what are some of the main components, part of the reference architecture, just to help, get everyone's bearings aligned here.
Yeah. So look, there's quite a few elements, and obviously they all fit together as a cohesive whole. So they're all part of a larger design. And of course, there's, depending on the scale you want to design at, so 1,000 GPUs, 8,000 GPUs, 12,000 GPUs, the elements scale slightly differently in each of these. But the common elements throughout are, obviously there's the compute nodes. So we talk about HGX, which is our SXM or NV-linked GPU architecture there. And there's a few different GPUs you can actually use there. So we talk about our H series, Hopper series, Blackwell coming, but also if you want to be inference optimized, there's the L40s, L40Ss. So a couple of different options there in terms of design. But regardless of which manufacturer you go with there, there's this rigorous standards that we impose on them to make sure that they do perform really, really well. So you've got choice, but you've got outcome, which is really critical. The networking piece is something that often confuses people a bit, in that there's sort of two networking parts here. So we talk about the compute network and the converged network, or for those of you with the network based east-west versus north-south. So, as many people who've been involved in high performance compute for many years know about, InfiniBand is the network of choice for scale out, multi-node training and the like for high performance compute as well. So InfiniBand is there for a really, really important reason. So we talk about the rails, which is accessing the GPUs. A lot of people ask, can I just put in my Ethernet network here? InfiniBand's there for a reason. We want to make sure those GPUs are fed and optimized. Nobody likes a hungry GPU. If you get GPU starvation, you're actually looking at a non-performant environment. So you want to make sure they're really, really well fed. And the non-blocking architecture of InfiniBand really caters for that very, very well. And more importantly, it's not just there's some hardware that runs fast, there's some software on top of that as well. So we've got our UFM and a few other components there with a base command and manager to make sure that's all really well managed. But we also have the converged network north-south as well, catering for that. So that's our Spectrum architecture. And of course, that's where we've got access to the storage componentry as well. We have our Bluefield 3 architecture built into that as well. So it provides some really interesting high-performance management capabilities. And of course, you need to have the out-of-band management as well, catering for that across all the components, which is actually included in the Bluefield piece. The last one, and I'll let you sort of touch on that a bit more down the track, is the high-performance storage. And it's funny, people hear the word storage and they often think different things about storage. And, I think really importantly, and, to the core of this, webinar, we talk about this. This is not just a place to store data and let it sit. The data, the active use of data, the management of data, the recycling of data, the operations of data, how you handle that and what you do with it is actually really, really critical. And I talked before about, making sure that the GPUs remain well fed. So its speed is obviously a really important part of that. But the cyclic nature of what people do throughout their AI journey, whether it be traditional AI or generative AI, that's really, really important as well. So making sure that A, it's fast, but B, you can do all the different things you want with it. And again, different customers want different stuff, as well as, and again, to this whole piece here, the multi-tenanted nature of this as well. Because for those of you with a CSP mindset, this is okay for one customer, but we need to cater for multiple people as well. So making sure that multi-tenant aspect is catered for is really critical as well. So quite a few different elements, and they go into lots of little details and bits and pieces, and the minutiae is actually quite important. But again, we make this really simple for people to consume. And needless to say, we have our solutions architects who help every customer, every CSP, work with this and make sure that it's designed well, fits into your data center, you've got the capabilities to manage it, and you're fully aware across all the design pieces as we go as well. So huge
Yeah.
element.
Yeah, I mean, I think the network, we'll touch on the high performance storage piece obviously in a little bit, but I think the networking piece, just to double click on that, right? It's funny because I remember like a couple of years ago, or maybe it was like 3 or 4 years ago, when people were first starting, everyone thought, okay, cool, AI is coming onto the scene. Let's just assemble a bunch of servers with some GPU cards in them, throw them onto a standard data center IT network, and we're off to the races. And as you mentioned earlier, like that is not how HPC centers have built infrastructure. So it's probably well understood in the HPC community. But as AI is kind of moving more mainstream, this might be a new area of focus, and that might, well, it seems a little daunting probably to some folks who haven't done it. I think the beauty of this reference architecture, what you guys described, is this is a proven blueprint where NVIDIA has actually built, designed, tested, validated, right, from a networking perspective. Using InfiniBand the proper way, building different north-south fabrics for storage and other data services, right? So I think that's super important, and probably on a personal level a key takeaway for many on this webinar. So I think you mentioned this earlier, right? But there's a lot of value for any service providers out there and any aspiring NCPs to follow this reference architecture, right? I just talked about the scale and kind of the peak performance that you get out of this, but maybe you can touch on a little bit around just the efficiency and elasticity and the others as well.
Yeah, look, these are all really important components, and they're actually critical when you're providing cloud services to customers, and customers plural as well there, right? So you need to make sure, and as you said, this is not stuff that you've done in a traditional enterprise unless you've got a HPC stack for Rapids or something like that for a while. So making sure that you can cater for both a scale and performance at scale, that's really, really critical. And again, the different layers, are you doing deep learning training? Are you doing generative AI training, or with model creation, doing model fine tuning? Are you doing inference piece? What you do in each of those and how you service those workloads are really, really key. And again, the efficiency of that, running it well, and the elasticity piece, again, customers, if they want to build this on-prem, that's one thing, but they're coming to cloud providers because they're bouncing up and down in terms of utilization. So how do you cater for that? How do you scale that out? How do you change the workload and do the different thing at different times? So that elasticity piece is really, really important. And you've got to be able to manage that. You've got to be able to perform that. And the full stack piece as well. So we're talking about multi-tenancy, but I prefer to focus a little bit more on the model stack or the software piece at the top here. This is really important to make sure that, do I have the tooling and services? Because a data scientist, they love GPUs, but they also don't use the GPUs. They use the software on top of that to drive the GPUs. That software piece really actually makes a difference. And that's, again, up and down the stack for management, but also for the data science piece as well there. And latest and greatest tooling. You can't have the stuff from, last month because a new model's been released or people are doing different things. So there's a few different needs here that you need to service for the customer, but also for yourself as an NCP in terms of what you do and how you orchestrate all those workloads and customers.
Yeah, I think the software and the application piece is super important, sometimes often underlooked. That's a good segue, right? So, I don't know if many people understand this, but NVIDIA obviously has also not just hardware, GPUs, like you said, but there's an entire host of a variety of different software packages and solutions that is available, right, for all different aspects of an AI workload and an AI pipeline. So maybe you can quickly just kind of explain for the audience like what this is for those who may not be familiar and think NVIDIA is still a GPU card maker.
Yeah, look, and with the number of people we have working on software versus hardware is quite mad, actually. It's quite a surprising number and people aren't aware of it. But the NVIDIA AI Enterprise Stack is pretty much precisely what it says. It's a stack that we've created to service enterprise needs, in this case, NCP needs. So there's really a couple of different layers here. The bottom layer does focus very strongly on the infrastructure management. So we've got our GPU operators, our network operators, our base commander manager is built into this here. So in terms of the operations and functionality, it provides all that you need there. That's the first part. The next middle part of the layer here is really where we have the frameworks for all the AI stuff. So, for example, in the generative space, we talk about our NeMo framework. So NeMo provides capabilities for our tooling as well as plugging in other tooling for elsewhere. So we talk about model management, model deployment, and again, in terms of lifecycle from beginning, where you might be doing training versus the end where you're doing inferencing, different things you need, data curators, our scale out inference deployment with Triton. Quite a few different elements are built into this. Probably the one that's garnered the most interest of recent times is down that inferencing piece. And if you want to think about sort of inferencing as a bit of a service, as it were, to the customers, something called NIMs. So NIMs is built into this as a microservice, and it's the NVIDIA inferencing microservice. And this is actually, new models are being released all the time here, but the challenge that a lot of customers face when they get to that final part is, again, them making sure their stuff is optimized for inferencing. And often, if you've got a bespoke stack, it can be a little bit tricky to put it together, and then it doesn't run as fast as you'd like it to run. So we create pre-created NIM stacks, which are very simple to upload into your stack. You can pull it down from our repository really, really rapidly, pre-optimized, anything from ServiceNow to video to voice. So many different capabilities here, which allow you or the enterprise to deploy that on their tenant really, really rapidly. And they get a fast scale out inference, and it just works. And so again, whether we're focusing on the client facing component at the top layer or the infrastructure management at the bottom layer, we build that into the stack with NVIDIA AI Enterprise. And it's got a lot of value in there.
Yeah, I love it. I personally have been digging into this entire stack over the last several months, dusting off my old computer science degree, putting it to good use. But I think the interesting thing is that, like you just described, right, a lot of those different components, different layers within NVAIE is used across the entirety of a life cycle of an AI workload, right, or workflow. And I know we have different, you have this slide that you prepared, but I have a different slide as well that I'd love to talk about. But maybe you can walk us through just, I think this is an important thing. We talked about this before the show, that most of the industry over the last 18 months, from my perspective at least, has been really enamored with the model, the classic kind of model training on thousands of GPUs. It's a very complex thing, right, to do. But the reality is it's bookended by a bunch of other processes and parts of a pipeline, effectively, right, that have to happen somewhere, right? If not in a service provider, it's happening on-prem or somewhere else, right? And then there's this continuous kind of cyclical nature of these pipelines that happen. So maybe you can kind of take the audience quickly through this slide in terms of like some of the key phases. I know this is an oversimplification, obviously, but maybe you can walk us through really quickly, from data prep through training to inferencing and deployment, et cetera.
Yeah, look, it's interesting because probably one of the most common questions we get from the end user customers, if I paraphrase, is how do I AI? I don't know how to get started and what to do and what are the bits. Can you inform me and educate me? And we're very lucky that we deal with so many different customers. We see so many different parts of the journeys and pitfalls and challenges and what works and what doesn't, or how you learn rapidly and that sort of stuff. So this is really a bit of a breakdown for a lot of customers around, okay, your journey will look like this roughly. And where are you today? And what do you need? What are your needs on that? And again, those needs are, to your point, hardware or software. So the scale out for training versus perhaps not quite the scale out, but high performant inference. But it all starts with data. So, do you have the data? Do you need to prepare your data? So ETL, are you going through ingestion phase? What the curation piece. So that data prep piece, and again, this pushes down on storage and compute in different ways. versus do you want to create your own model? And not everybody does, but there are some people who will say, I need a couple thousand GPUs for a few months to do that model creation. And again, this is where the sovereignty piece comes in, either data sovereignty or national sovereignty around models and the like. And they may use those models purely internally or service them out elsewhere. Whether or not somebody builds in a RAG pipeline to that as well. So no, I'm not creating my own models from scratch, but I'll use RAG with a bit of a via an NCP. I'll do the on-prem capabilities here with a hybrid cloud. Again, data sovereignty is big in that, but we're talking about inference here. And the other piece at the end there, and this is where a lot of customers get quite nervous about pushing models out customer facing versus internally facing, is do I have some guardrails I can build around my generative AI to make sure there's no hallucinations or it's bounded in domain knowledge, so it's a finance chatbot or a HR chatbot or customer service chatbot and doesn't do anything inappropriate. And guardrails is actually the name of one of the pieces of software in Nemo to make sure that you do have those boundaries there. So depending on what elements you need at each of these preparation, operations, or deployment phase, you need different tooling. And this is also a trajectory piece as well. So one of the great things that I personally love about this slide is ensuring that people are saying, okay, I'm here, but they're not heads down into, I will only do these things or cater or design for this now, but a design for the elements that I may need later on as well. And they're open to that, again, at both a hardware and a software layer to make sure they get the entirety of their journey. And again, this is really relevant for NCPs because you're going to have customers at different phases. And as people go through the journey, some of them, like with our NIMS products, might jump straight to the inferencing piece. Whereas others go, again, language specific and region for me is I need to create my own model or I'm going to customize it slightly. So different things for different people. And again, the questions you ask determine the answers you get. So it's good to have a really broad understanding of what your long-term life cycle may look like here, which I really like this.
Yeah, and I think like you said earlier, I like the question on the bottom, right? Where are you in your journey? Because to reach the widest addressable market as a service provider, you have to understand the kinds of audiences or the kinds of customers you're going to be attracting, right? So thinking about this kind of end-to-end and holistically, your customers, depending on where they are on the journey, may have different needs, different requirements. And so if you hone in on just a one slice, right, of this pipeline, of this workflow, then you might end up alienating other users or potential customers of yours instead. So, well, on that note, I will take just a quick moment to talk a little bit about some of the recent things that we've done here at Vast Data with NVIDIA, and I'll try to get through this quickly so we can have some time for some questions at the end. You know, Vast Data, we've been working with NVIDIA for probably 6+ years now across a variety of different areas, from networking to being an early DGX SuperPod certified partner to just most recently our announcement last month around us becoming one of the first NCP high performance storage certified partners in the field as well. So there's a couple of resources. I don't know if we're actually going to link those later, but they're available on our website, different kinds of content if you want to learn more about the specifics about the reference architecture that we've jointly developed with NVIDIA for NCP. And you can take a look at some pretty fascinating, insightful blogs as well. One of the interesting things, just like, and I apologize, I am making my screen a little larger because my eyesight is getting poor. But one of the interesting things that Michael mentioned earlier, just that, you know, NVIDIA's had great access to just such a diverse set of customers that's given them kind of the direction of what they need to build. Here at Vast, we've had kind of a similar journey in a different way, right? We are now powering multiple dozens of some of the world's largest AI cloud service providers from a data platform perspective. And here's just a handful of some references that we'll talk about a little bit later today. But, you know, I think one of the interesting things that we've learned in working with these partners is it's not rocket science. I mean, there's some really critical requirements that you think about as a service provider. availability and uptime is it's your namesake, it's your reputation. The uptime and availability is critical, and that's something that we at Vast are extremely proud of. Is that our platforms tend to run around 6 nines of availability across now hundreds of petabytes deployed globally from these service providers. Michael mentioned multi-tenant security, access controls. The multi-tenancy aspect is, I think, sometimes far underappreciated, especially when it comes from a data perspective, right? Being able to ensure encryption per tenants, access controls per tenants, network segmentation, also things like QoS, right? Which is not security oriented, but it's still part of a multi-tenancy platform requirement. Also, one of the things we talk about, just like in the slide you saw from Michael about the pipeline, and we'll go into more detail just in a second about this, but oftentimes when you look across the stages of pipelines, there's different requirements for storage needs for different phases of those pipelines, from data prep to training to inferencing and so forth. And having a single platform to be able to consolidate things like Scratch or Home Directory or data prep storage or inferencing logging, whatever it may be, is a huge TCO boost for service providers, because you're not having to build dedicated purpose-built infrastructure for every single stage and every single potential stage and customer that you're looking to onboard. We're also very proud of the fact that the system was built. When I first joined the company almost 5 years ago, I told our CEO that the design and the architecture of our platform felt like it was built for the service providers. And while it took us a couple of years to start really focusing on the service provider market, we've had things like zero downtime maintenance windows. Like, we don't have maintenance windows. Zero downtime for things like upgrades, patches, etc., is critical for service providers. So you don't have to have a notice out to your customers about taking a Sunday off and being able to patch systems just to continue to operate. So that's something we're also very, very proud of. And then lastly is I think one of the most interesting things about the feedback we've heard from our service provider customers and partners is that when you look at a platform like the Vast Data platform, we actually unlock additional revenue streams, because it's no longer just a singular storage service, but there's also additional capabilities that you can introduce that are additional cloud services that you can offer to your customers too. Sorry about that. Okay, and when speaking about the Vast Data platform, this is kind of what it looks like for those of you who may not be familiar with our system. The Vast Data platform is a single exabyte scale namespace. You could think of it that way. But there's really 3 main capabilities that are built into the same single platform. They're not different products, not different clusters. This is literally the same platform ubiquitously. The data store is probably what we're most famous for, and this is where we've partnered with NVIDIA for high performance storage specifically, which is a means of providing very, very high performance file system access, right? So you can think about us to some degree like an enterprise NAS and object storage system. We provide support for NFS and SMB and S3, and also things like RDMA access over some of those protocols to give you things like GPU direct storage as well, supported out of the box. But more interesting is we also offer additional capabilities, something we call the Vast Database, which you could think about as a multi-petabyte data warehouse construct. And this is super important. I'll touch on it in just a second. But again, this is something that's now natively in the same platform that can be used for things like data preparation, right? For doing ETL, accelerated ETL, as an example. And then soon we'll be unveiling a preview for the data engine, which will start to introduce a little bit of a lightweight computing platform to do things like real-time eventing or real-time data processing via functions on the platform as well. And so when you think about all of those different capabilities, it's important. If you think back to apologies, I'm having a little problems. Boone, if you could click next slide for me, I'd appreciate it. Thank you so much. The slide that Michael showed earlier around kind of this journey, right, from an AI application pipeline perspective, this is a little bit of an eye chart, a little bit more technical, but it's there to convey the same point, right? So when you think about the journey for any AI application builder, right? Either someone who's actually an AI company, someone who's training LLMs, or someone who's deploying AI applications. There's a whole bunch of different phases that actually have to happen. It's not a singular application that you just do and call it a day, right? So everything, when we think about this from a pipeline workflow perspective, we talk about things like data ingest, right? We also talk about things like data preparation, just like in Michael's slide. There's the training phase. There's obviously the inferencing phase, the deployment phase as well. And if you really drill down into each of these different stages, you'll quickly understand that there's actually different kind of application processes and different storage and data requirements for each of these different stages. And so again, like I mentioned earlier, instead of having to have different dedicated solutions and technologies for each of these different phases, we're very proud of the fact that we provide some unique capabilities that span all of this end to end on a single platform. One of those examples, just to kind of, Boone, if you could hit next slide, please, just to kind of illustrate what I'm talking about is around data preparation, right? So data preparation, by far, if you look across the industry, the most commonly used tool for data preparation is Apache Spark, something Spark oriented to do large ETL. This is where you'll do filtering of data, cleaning of data, transforming of data, all of these operations that you have to do before you can even start a large training job or a training run for a model. And here's an example where with the vast database, that capability has a native integrated Apache Spark plugin, which provides radical acceleration. When you combine things like that from VAST, plus the fact that many people may not know this, but NVIDIA also has a data analytics offering called Rapids. When you add those two things together, you can start to see radical acceleration of these traditional Spark workloads by an order of magnitude, oftentimes, depending on the type of queries and type of jobs that are running. So I won't go into too much more detail on this slide, but just as an example of thinking about the different stages of an AI pipeline and what you might need to offer your customers in order for them to bring all of their kind of workload onto your infrastructure moving forward. Sorry. Okay. Yeah. And lastly, right. So this is kind of one of the things I mentioned earlier on the slide as far as benefits is the consolidation. And this is another way to think about it, a simplified view. But we do have this concept of having a single data platform that allows you to consolidate many of the different stages of an AI pipeline. Our focus on the NCP reference architecture is clearly around delivering high performance bandwidth, high performance throughput for things like checkpointing and restores during the model training. But we also have a bunch of different capabilities, like I just talked about with the database capability for things like Apache Spark. So, just something to keep in mind. All of this is built with multi-tenancy, with QoS, with security, with data protection woven throughout the entire vast data platform, end to end, for the entirety of the pipeline. Lastly, just as an example, and then we'll get into some questions here in the last 10 minutes or so. We have a whole bunch, like I mentioned, now multiple dozens of service providers all around the world. One of the ones we talk about here in the United States often is our friends at Lambda Labs, who are building both. Now I think they're focusing specifically on their public cloud and their Lambda cloud, which is a multi-tenant GPU cloud, right? And they're getting a lot of the benefits that I described today, leveraging the vast data platform as their underlying data provider. If you go and if you're interested in learning more, we have a bunch of public information case studies. I don't know where that QR code actually goes, but if you go to our website, vastdata.com, you'll find more information about some of the radical infrastructure savings that they've been able to observe, as well as how they're implementing some of the zero trust natures of our platform for better security and better encryption, better authentication, et cetera, et cetera. So, and with that, I'll hand it back to Boone, and maybe we can dig through some of the questions in the next 6 minutes or so.
Perfect. And for folks, if you don't know where to find the Q&A, it's on the right side of your screen. You can click the Q&A tab and drop a question in there, and we'll take it live here. while we're waiting for questions coming from the audience, we got a few coming in already, actually. We got a few questions that have we've seen come up from customers kind of time and again. So starting with this first one, what are some of the bigger challenges that customers face in AI adoption today?
Michael, I'll let you go first.
Yeah, it's a good one. I'd say honestly, and I say this with respect, lack of knowledge or preparedness for what needs to be done and where they need to go. So again, directional and longitudinal success in infrastructure and knowledge. These are different things. These are different times. And look at just the change from traditional AI to generative AI in the last 18 months. So making sure that you get educated around where you need to go long term and what the requirements are across, and I say this for a customer, and it's slightly different for an NCP, across the entire enterprise. So what the IT team needs, what the line of business needs, and what data scientists needs, they're all slightly different, but they all need to be serviced appropriately, right? So I'd say knowledge and preparedness at an organizational level is a key thing.
Yeah, I think that's a definitely the skills focused aspect. There are obviously other tangible commodity-based challenges that people face today from an AI adoption point of view. Everyone knows that things like having power and access to GPUs is obviously critical. But like we talked about earlier, I mean, I think success, at least through the lens of a service provider, in my opinion, all boils down to who do you ultimately want to cater your offering for. If you're thinking about standing up a large investment of GPUs, and the kind of this build it and they will come model, then you really need to think this through end to end as far as like what parts of the AI journey and the AI pipeline do you want to accommodate within your offering, within your portfolio? Because if you don't, you're going to end up in a situation where customers will come to you just to do a part of their workflow, and then they'll have to still use maybe your competitor or some other service to do other parts of it, and that's an opportunity lost, in my opinion. So.
Another question here. What are some of the bigger challenges that customers face in AI adoption today?
I think that was the same question.
Apologies. I got him out of order here. Where is it going in terms of new use cases and initiatives?
I'll give my quick take on this. I think over the last 18 months has been an oversized focus on larger and larger AI models. And what I've seen, at least in the last 3 months even, is people are starting to revisit even smaller models and focus on deployment, right? Focus on how do we actually build better models for inferencing, for example, right? So training is a very expensive operation, obviously. And I think that enterprises, other businesses, organizations, there's quickly more and more focus is shifting to how do I actually get productivity out of all these investments that happened over the 18, 20 months, 4 months previous. And so that's kind of what I see. I know it's a broad statement, but a lot more focus around inferencing is starting to make its way.
Sure. Yeah, I'm going to echo that as well. In the early days of especially generative AI, people wanted the grand unified model that does all things throughout their entire business and it'll solve all the problems. And it's very rapidly, people are realizing that's not the case. So domain specific or vertical specific in some cases, rapidly deployed inference models, which may be quite narrowly targeted to specific use cases, whether it be a RAG or just a pure inference model, actually create a whole lot of good. I'd say probably one of the most common ones would be I'm going to call it a customer service environment. And again, that may be inwardly focused versus outwardly focused, but again, very domain specific. So how do I tweak this? How do I tune that? What's a common problem here? Whether in telco, financial services, medical, lots of stuff. These things are really, really good and really help with customer service and satisfaction. But narrow deployments for inferencing, absolutely way to go. That's where the smart customers are getting.
I think the laser. It's one more thing. I think the laser focus. You just triggered a thought in me. Like the narrower the models, they're getting better and better at doing specific tasks. And I'm seeing more and more people build kind of both agentic systems, but also building compound systems around like multiple models to fulfill a more complex task, right? So that becomes super interesting. Gets even more complicated from a pipeline perspective too. So.
Yep.
John, we got a question from our audience here about around how VAST compares with some competitors. I'm not sure if you're comfortable taking that one live here, or if we need to direct folks to their kind of local VAST resource, but they're asking about IBM Spectrum Scale, for example.
Yeah, so Spectrum Scale GPFS, it's a great product. It's been around forever, right? It kind of has origins in the HPC space. I think, like I said earlier, my view, and I won't go into like speeds and feeds comparisons, because I think at the end of the day, given enough hardware, all of these modern day and even legacy file systems can scale. They can go pretty fast, right? So I don't think that's the issue. I think the biggest difference when you start looking at it gets into more at the data platform layer, right? So for example, we here at VAST, we are not only a high performance file system, but we're also a high performance object storage system. We're also a high performance data warehouse, right? All in one. And while you might not understand your customers' requirements, I challenge you to go look at the pipeline story again and kind of understand what your customers have to go through to be successful. And I think that will help open some eyes. We hear this all the time, right? Like we see them doing these types of workloads on our systems from some of our service providers today. So it's not I guess the too long didn't read short summary would be, it's not only a high performance file system, it has also got a whole bunch of other data services that could become cloud services for you in your context as well.
And I think, and John, thank you so much for, not John Mao, John Chen, thank you so much for your other question as well. I think that John answered that question as well with your, with his answer there. With that, we're actually quite, we're at time here. So we've had quite an interactive session. Thank you everyone for your questions. I will go ahead and share one last slide with you all. So you guys may or may not have heard about Cosmos. This is our upcoming event here at VAST. In fact, I'll flash across the ticker here a way for you to register for this. But this is there's not much that we can share with this right now, but what I can tell you is this is going to be a very exciting event that's coming up in October, and you'll definitely want to get registered for this. And
it's going to be a good one.
It's going to be a good one. And yeah, for those of you that attended Build Beyond last year, I'll throw this down here at the bottom of the screen so you can access this. For those of you that attended Build Beyond last year, which was a big launch event we did last year, this is building upon that. And so definitely register for the event, and we hope to see you there in October. But with that, thank you so much, Michael, and thank you so much, John, for presenting, and thank you for everyone that came and attended today.